First, we're going to label the different forms of conic sections. We have this one and we have this one. They look very, very, very similar. Do you guys see the only difference? The X and the Y are switched, and that helps determine like what type of hyperbola that you are dealing with. Yeah, so take a look at the printed paper. And it has the forms on there. So for this one, what type of hyperbola do we have?
Horizontal.
So when X is listed first, you open in the X direction. So you open left and right. That's how I remember it. And then when Y is listed first, you have what kind of hyperbola? Vertical. And I'm going to go ahead and sketch a little image so that we know that horizontal is like that. Vertical is like that. Notice the placement of A and B. So they stay the same regardless. That means that you aren't necessarily stretched in the direction of that you're opening or anything. So make sure that you take note that A and B are fixed positions. And I'm going to go ahead and write down the formula to find C, or to figure out focus points. C squared is equal to A squared plus B squared. So this is opposite of the ellipse. The ellipse formula has a subtraction right here, and this one has an addition. If you forget and you do subtraction, what would happen is that your focus point isn't inside your curves, and that's where a focus point goes. It has to be inside the curves. So if you ever get the formula mixed up, that's probably what you did, is that the sign is wrong. Let's keep moving. Let me move this down just a little bit. So the next problem says identify all the key features and graph the hyperbola. So here is our hyperbola. We can take a look at who is listed first to figure out, is that going to be a horizontal or vertical hyperbola? Horizontal. So I'm going to go ahead and give myself a reminder that it'll look like that. And then A squared is always listed first. So I know that, don't copy that. A squared is, 4 is the same thing as what squared? 2 squared. And 25 is the same thing as what squared? 5 squared. So I know what A is. I know what B is. A is 2, B is 5. So A is not necessarily the bigger one anymore. To figure out C, we could do that, right? So let's use the formula. And it's the same thing as the square root of A squared plus B squared. And we already have them squared, so it's 4 plus 25. So we get the square root of 29. So if we were graphing, or if we were taking the test without a calculator, the square root of 29 is in between two perfect squares, where it's in between the square root of 25 and 36. So the square root of 25 is 5, and the square root of 36 is 6. So it's a number between 5 and 6. Is 29 closer to 25 or closer to 36?
5.
Okay, so it's going to be somewhere less than 5.5. So let's say 5.4. We don't have to have an exact value. We're graphing. Like, nobody's going to know if you plot 5.4 or 5.6. Nobody's going to even know. It's somewhere between 5 and 6. So that is our C value. Our center. You have to be really careful with hyperbolas because X and Y can switch places. The fraction for X and the fraction for Y can switch places. So just make sure to remember that the center is always HK, or it goes with the X and the Y values. So H is here and K is with the Y. So this one happens to be in order, so it's not as confusing, but sometimes you'll have the Y fraction listed first. Make sure you switch them for the center. So what is my center? 2, 0. Very good. My center is 2, 0, and it has parentheses. My vertices, I could figure out my vertices. I know that from my center, wherever my center is, I would be adding and subtracting in the X direction. So it's the X value that's going to change. And so the A is in the X direction. So I would add and subtract 2 to X. So if I subtract 2, then I get 0, 0. And if I add 2, I get 4, 0. I think it's easier to graph it, but you could do it like that. So I'm going to start getting my graph going. My graph, it's going to have a center at 2, 0. So over at 2, 0, I put the center. In the X and Y direction, I have in the X direction, and sometimes I like to label these. So this is under the X, so that means that left and right, I'm going a value of 2, up and down, I'm going a value of 5. So I'm just putting a point left and right, up and down. So left and right, I'm going to go a value of 2. And that's where the vertices are going to attach. And then up and down, I'm going to go a value of 5. These are where the co-vertices would be if it asked you a question about co-vertices. Co-vertices are the helper ones. Nothing actually attaches there, they're helpers. When you make a hyperbola, this is totally different than any other conic section. We're going to actually create this box, and these tell us how we make our box, and I'm just making dashed lines to create this box. And it's going to be a little bit more difficult for me to sketch. Does everybody see my little lines? They're kind of small. What? You go up and down 5 in the Y direction because it's B, and then left and right 2 because it's in the X direction. Okay, these are not part of your graph. These are guides for your graph. Next, we're going to create an X from corner to corner through the center. This is going to be very challenging for me with my little stylus, but I'm going to try my best. So I'm going to create a dashed line. It'll go through the corner to the center. Do the very best you can. You have a straight edge. I don't have a straight edge on the computer.
Oh, wow.
And make it big. So I made, maybe I should have used green. Next one I'll use green. So I made my rectangle. It could be a box, but I made my rectangle. And then I make diagonal lines through the center. The diagonal lines are super helpful because they actually create a guide. So my hyperbola is horizontal, so it's going to open horizontally. And so I'm going to anchor at my vertex point. So these are my 2 vertex points. And then I'm going to create my curve. My curve, I'm going to do my very best. It's not too bad. Put your phone away.
I was using my pocket. In my Jenny.
And then I'm going to create my hyperbola attaching to these are called branches of your hyperbola. Beautiful. So that is my hyperbola. I just followed the path of the asymptotes.
Oh. Oh, I see.
So I'm following, those are all a guide. That's why I made my X's really big, my diagonal lines. That's why I made them really big. So So my focus points, I need to figure out what my focus points are. And so to figure out your focus points, same thing in the direction of the vertices, we added subtract 2 to 0. Well, now in the same direction, I need to add and subtract the C. C helps you find the foci or the focus points. So I need to add and subtract square root 29 to the value of 2. So this is how you would probably see your answer on a test. 2 plus and minus the square root of 29, comma 0. But for the purpose of us graphing, we kind of need to know better answers than that to kind of know where to put it. So we're really adding, subtracting about 5.5 to 2. So if we add 5 to 2, we get about 7.4. And if we subtract, we get -3. Bless you. Hold on. Okay, yeah, we get -3.4. That's what I had written down. I just had to double check myself. So these are my two focus points so that I know where they're going to go. So I know that I am subtracting to -3.4 over here.
No, it's -3.6. You typed it too. He's like, okay.
Yeah, no, I just typed it in. 2 minus 5.4, -3.4. And the reason why is because we're going 5 and then an additional. Oh, it's because we're going that direction. That's why. So
Oh, okay.
yes, because we're going that direction. It tripped me up too. Had to check my math too because it didn't feel right. So we're gonna go to -3.4. And honestly, does it really matter if you know the exact decimal? Nah, not really. It's somewhere between -3 and -4. Same thing in the x direction. It doesn't really matter where you put the point. It's somewhere between 7 and 8. So over here. Yeah, right on. Yeah, it's outside the graph. So these are my two focus points. Asymptotes. There's an equation on your other blue paper. There's an equation. So we're going to use that as a guide. So you have y is equal to plus and minus b divided by a. And then you have x minus h. So when you have, is that correct? Oh, let's fix it. Hold on, hold on, hold on.
No, it's back since she fucked that.
Oh, okay. I don't want to put the y minus k piece. Okay. I didn't put it because the k piece was 0. I thought you were saying that where my parentheses are, I should have the k, and I was like, I'm almost willing to bet money that that is not true. Yes, so right here, yes, technically it's y minus k, but the y value is 0. That's why I didn't put it there. Sorry. So when I write my equation, and to kind of remember this formula, and yes, technically it is y minus k. So if you want to put that, you can. I skipped a step. I shouldn't have. Y minus k. This is the part that is trippy for us, is this part. So you have to remember that when you're dealing with a horizontal parabola, it's going to be b divided by a. And then when we do the vertical parabola, it's opposite. It's a over b. It just is. So our asymptote for this one, y equals our b value is 5, plus and minus. 5 divided by 2, and then x minus h, so x minus 2. These are the equations for my asymptotes. Did I need the equation to actually draw them? No. No, I didn't.
Excuse me. Excuse me.
Let's do another one because that would be fun. Our next equation, the problem with this one is this ready to graph?
No.
Nope, it's not ready to graph, so we're gonna have to complete the square. And y'all should be getting lots of practice with this so far. And one thing that you need to know is like what we're trying to get to. So keep in mind that we want to get to this form right here where we've got two fractions. And so the equation for example 2 has the squared piece is y. What we have listed first is the y piece, and then we're subtracting the x piece. So it's going to have the y fraction first and then the x fraction, and hyperbolas and ellipses are always equal to 1. So coming back here, again, the reason why I know that this is a vertical parabola is because we are subtracting the x value. So I'm going to get things ready to complete the square. I'm going to have 9y squared. And there's nothing to, you only have to complete the square with the terms that have like the x squared and then the x. And then I have minus x squared. And I'm going to complete the square here. Getting myself ready, I'm factoring out the negative. So this is going to be plus 6x. And I'm going to complete the square. It's always plus. Equals, and I need to bring the 10 over. I have to add 10 to the other side. And I need to, right here, I'm dividing by -1 technically. So I get 10 on the other side, and I'm going to be adding something over here. And before I complete the square, I always write my next line. And I already know what sign is going to go here because it's the same as the b value, so it's going to be a plus right here. To complete the square, I have to do b divided by 2 squared. So in this case, my b value is 6. I'm kind of doing this off to the side. So b divided by 2, what's in parentheses goes down here in parentheses. So 6 divided by 2 is what? 3, that's what goes in parentheses, and then I work my way up when I complete the square. 3 squared is 9. Okay, here's where it's tricky. I am not adding just 9. I'm adding 9 times -1 because out here is a -1. When you do hyperbolas, you have to remember that part. So it's not 10 plus 9, it's actually 10 minus 9. So what do you get over there? 1, which is nice because we want it to equal 1, so that's actually pretty good. From here, I cannot have a coefficient other than 1, so this is an issue.
Why is it -9?
Because I have to take into account that in front, I can erase this and show you. I factored out that -1, so technically what's right here is a -1. And anytime you complete the square, it's not just you're not just adding this piece, it's
So
9
technically it's
times
still a
-1.
x squared, it's just separated.
Yes. From here, and this is gonna look strange, but I cannot have this piece right here, and we don't even look like a hyperbola because hyperbolas are fractions. So this is the same thing as
Y squared divided by 1/9
you're so smart.
minus x plus 3 squared over 1. Equals 1. Always equals 1.
Always equals 1. Now, here's the thing. We're going to need A, B, and C to be able to graph, so we could also rewrite our denominators as something squared. So this would be y squared over 1/3 squared. And 1 is the same thing as 1 squared. Now, this is actually there we go. Now we have the equation of a hyperbola. It's in standard form. We are good to go. What is the A value? Okay. What is the A value? 1/3. What's B? 1. Okay, we could solve for C. Let's do that in a second. What kind of hyperbola? Horizontal or vertical? Vertical, because the y is listed first. So we have an idea of what that's going to look like. Bless you. We have an idea of what it's going to look like, so we know which one our vertices are. Our center is still always HK. So what is my center? -3, 0. So be careful. H is second. So be careful. The vertices, the foci, the asymptotes, we're going to get to those. We need to figure out C. I didn't realize I had a graph right here. I have it different on my paper. So I'm going to have to come up here to make myself some room to find C. C is going to be, or C squared is equal, no. I meant to write C. C is equal to the square root of 1/9 plus 1. So, yeah, but we need I want y'all to be able to know what it looks like when you take your test. So if we added these together, we would have to have like denominators, but it's easy. I can change 1 to 9/9. Isn't that the same thing as 1?
Mm-hmm.
Yeah. So now I get the square root of 1 plus 9 is 10/9. On-ramps is probably not going to leave it like this because 9 is a perfect square. So this is the same thing as the square root 10 over the square root 9. So you can break up the square roots to look at the square root of the top and the bottom independently, or the numerator and denominator independently.
So square root of 10/3?
Yes. So we get square root 10/3. Okay, square root 10 is really close to the square root of 9, right? Yeah? What's the square root of 9?
What?
What's the square root of 9? 3. So square root of 10 is just going to be just barely above that. So if we were looking at an approximation, like this is pretty darn close to just a little tiny bit above 1. So when we go to graph it, it's just going to be tiny bit above 1. I mean, technically it's 1.05, but does it matter that last little bit of fraction or decimal? No, not really. It's going to be just slightly above 1. Sure, that's fine. So when I go to graph this, you can figure out the vertices, and that's not really a problem, because for this one, you're moving in the y direction, and it's 0. It's easy to add to 0. And so in the y direction, and it's kind of a good idea to label it over here, I'm going to remind myself that A is in the y direction, so A is moving up and down. Oh, I'll put it here. Up and down for A and left and right for B. So since I'm a vertical hyperbola, I'm going to have my center right in the middle. It was hard for me to get that in the middle. And then I'm adding and subtracting to get the vertices. And so from my center, I'm adding and subtracting vertically, so it adds and subtracts to the y. And this is what goes with the y value. So I'm adding and subtracting a third. So my vertices are going to be at -3 minus 1/3, and comma, and then -3 positive 1/3, because I'm going to add and subtract those. Am I going to be able to plot something exactly at a third? No, I'm going to have to estimate. So I'm going to go and start labeling my graph. I've got my center is at -3, 0. I put a point. This one is a tiny little rectangle that we're creating. I'm going to make a different color, maybe green.
I like the small ones. I need a graph on them.
It's going to be kind of small. So for this one, in the y direction, I'm going up and down a third. I mean, it's just tiny, just barely up and down a third. To be honest, to make it easier for me when I'm graphing, I kind of go and I put it about a half because I don't have any room to actually see what I'm doing. So somewhere up and down a third, or somewhere between 0 and 1. And then left and right goes with my v value, and I'm going a value of 1. So left and right from my center, I go a value of 1. And then I create this little tiny box. I'm actually just going to make it solid so y'all can see it. But just know that it should be dashed so that y'all can see it. There's my little box. I'm going to make diagonal lines. I'm going to kind of make them large and in charge because our graphs,
Large and in charge?
they're big. They're biggish. And this is why after I had to do all of these steps, sometimes it's easy to forget which direction you need to attach your branches or your vertices. Since I am a vertical hyperbola, I attach up and down. So that's where I'm going to attach my branches. So here, there we go. And I'm going to use the asymptotes as a guide. Get my branches. And you try and make them as curvy as possible. My foci. So again, you're adding and subtracting in the y direction, and your center was at 0, so it's actually not that bad to write your foci like the way that you would see them in the answer key or like on a multiple choice part of your test. You would see -3, comma, plus and minus square root 10 over 3. That's my C value. They would never have this as a decimal equivalent unless we were doing a real world problem, and this is not. For my asymptotes, my equation is similar, but one thing that's different is the like the slope. So this time it's A over B. So our equation is y minus k equals plus or minus A over B x minus h. Correct me if I'm wrong. This should be the equation for the vertical one. Do y'all agree?
Yeah.
Yeah?
Yeah.
All right, so we're gonna write our asymptote. So the k value is 0, so it's just y equals plus and minus. We know our a value is 1/3, and we're dividing it by 1. So it's just 1/3. The only thing we haven't done is plot our focus points. So we know that square root 3 over or square root 10 over 3 is about 1. So over here where my center is, I'm basically adding 1 and subtracting 1 to put my foci are my foci, my focus points.
Excuse me.
So these are really, really close to the vertex. That is all the examples we're going to do.